Hi, my name is Edwin. I'm going to present on behalf of the duo team, William and myself, and the Prof. Sangyan. So we're going to touch on the Kellogg planning system. In short, we call it KPS. This is mainly focused on the linear programming model, optimize the Kellogg production, inventory, and distributions. We have mentioned this part of the reference and sources just for mainly for strictly for our educational purposes only, and then we will be focused more on the optimized Kellogg production, inventory, and distribution. All right. So the first one that we try to focus on is the background. It's a scientific literature based on our case study. Either it's a special for supply chain planning situation optimizing more regarding the entire chain. The model demonstrated in this case illustrated is well balanced applicable strategic operational planning situation. So the in design and management itself is supply chain management is the design and management of seamless value added process across organizational boundaries to meet the real needs of the end customer. Institute for Supply Management. Okay, so our team is interested in the case in view of real business investment opportunity. This is published well endorsed success story and best practice and innovative optimization method that achieve optimal best solution with a timely business decision mode. And most importantly, it is about optimization equal to efficiency plus saving that clearly demonstrated by this KPS case analysis that companies can turn to management science. So for the aggregates capacity planning, production, and scheduling kind of planning is that demonstrated an effective large-scale linear programming model, reduce production, inventory, and distribution costs, optimization operational plans, and increase collaboration among functional groups due to internal process integration. And take-home message is the KPS is an integrated production and distribution planning system which is yielding 35 to 40 million in potential saving. So there are potential problems or rather problem before introducing KPS due to the complexity of the situation as in five plants and be situated across if you can read from this slide that we mentioned and the variety pack which can be packed only at the Battle Creek alone. There are seven core distribution center. So all in all, it is really it's all about the complexity, and there is the challenge for a need for the optimal solution to save the cost against the complexity of the above condition. So we try to address this issue through the KPS. Also, the Kellogg company has the long used spreadsheet and like conventional system in the software material requirements planning, MRP and distribution resource planning, DRP, many different varieties of products and brands, packaged in many different sizes. So in 1987, they realized its expanding product line and resulted in developing KPS in 1985. Modified over time, by 1994, the strong cost system is in place and saved at least 4.5 million in 1995 alone. So the Keller planning system this guides operational decision, essentially a large linear programming model, and then forecast customer demands and the specify what should be produced and held and shipped on daily basis. Plans weekly production, inventory, and distribution decision. It was originally intended for the operational need daily and weekly, but extended also to a system for making tactical and long-range decision about issues of plant budgeting, capacity expansion, and consolidation. The it's added to with the added global condition optimization, the developing KPS. Therefore, the the based on information in the case eventually with the KPS implementation, the operation improved and also came out with the two version. The KPS is established in two versions. Firstly, an operational means that the provided weekly details that help to determine where products are produced and how finished products and processed products ship between plants and distribution center, including operational cost reduction. This is the formula that you can refer to, which is the in a red highlighted whole T equal to whole T minus T plus make T minus demand T. So basic operational linear program for all time periods, weeks, etc. So you can refer to it by yourself. And this is also be the KPS version is operational KPS. So now the next version says we have to focus on the tactical linear program model that is identical to the operational means that a set time period will be considered as 4-week block or months or transportation identified as instantaneous and model required time cascaded solution to deal with the limited product shelf life. As monthly level, the tactical linear program model helps to establish plant budget and make capacity expansion and consolidation in making decisions. And also the time cascade solution to deal with the limited product shelf life. So moving on to the next slide. So we are talking about the Kellogg linear programming considerations, whereas the basic objective of KPS is to minimize the local cost of meeting estimated demands and improve productivity that would include all these factors, such as purchasing, manufacturing, inventory, distribution, production costs, packing costs, etc., etc., and also the line capacity violation, and also the unmet safety stock requirements to provide the fresh product as fresh as possible to meet the customer expectation, minimize the total cost of meeting estimated demands, improve productivity. This is a take-home message for basic objective of KPS, minimizing the total cost. So moving on to the next slide, we have to focus on some of the considerations, the decision variable, which I'm going to touch on, like decision variables of the KPS at plant include production, process, packaging, inventories, and shipments. To take note that for this KPS, distribution centers incorporates only inventory and shipping variables while selecting the indices and data units are important factor top consider in establishing the decision variables. So you can refer to the some of the calculation that we put it there. The DC incorporates only inventory and shipping variables. Selecting indices and data units are an important factor. So moving on to the next slide, we are focusing on the consideration as well, the packaging capacity, flow, constraint, inventory, and safety stock. There are some of the points that we mentioned, and all the formulation are input over there. As stated in this case, the real scale of this problem could have covered 700,000 variable, 100,000 constraint, 4 million non-zero coefficients based on our reference. And this constraints this line processing capacities, packaging line capacity, flow balance between processing and packaging, balance inventory, coordination time, processing lines and packaging, and safety stock. So moving on to the next slide, which we cover on the difficulties in developing this KPS optimization model. So that's the challenges and critics that we have it over here. So the integral role in evaluate production capacity by investigating the utilization of various processing lines, whereby these are hard to model as in production inventory and distribution system that track the age of the inventory. The linear program models multi-stage production system it does not really model the raw material. The lack of flexibility, for instance, KPS might suggest that about one third of the shift of a low demand SKU be produced at some plant in each week. So the fundamentally a linear program is assumed that each decision variable may take on any value in continuous range. However, production and packaging decisions are not always that flexible. Possibly, KPS is effective modeling some immediate production only. So setting it in a weekly rolling horizon, but KPS does not model raw material as such for week one. All raw material would have been arranged. Thus, KPS could not change week one decision. So possible improvement is we try to, in order to overcome the above problems and difficulty with information technology, uh, improvement, however, and a mixed integer version of KPS to handle production and packaging setup is on the drawing board. So the managerial impacts and conclusion is very useful in both strategic and operational planning solution. It's proven in saving millions of dollars and optimizes production, inventory, and distribution. KPS is also very persistent in several ways. Scientific per se. Scrutiny for the central also eliminates the need to explicitly model the shelf life of perishable inventory. Use IT will be the use of information technology will better structure and change how to schedule production. Must evaluate the potential saving and variable costs. The take-home message is to maximize the profit and minimize the cost of product. Business leaders should be able to decide which model is best to derive, best suited to generate the largest benefit for their company. Thank you so much. This is the end of my presentation. Thanks for watching and thanks for listening. Please refer to the our slides and there was written very clearly on each of the slides. And please refer to that. Thank you very much. I want to thank on behalf of my duo team, myself, Edwin, and William. Thank you very much.